So today we're going to talk about direct variation. Direct variation is very related to this equation here that we've worked on a bit, the slope-intercept equation, y equals mx plus b, where m is the slope and y is the and b is the y-intercept. But with direct variation, it's even easier because in there it's y is equal to ax. A is just another name for slope. And what ends up happening is that there's no y-intercept. There's nothing added or subtracted on. So automatically 0, 0 is going to be a point. So let's follow this along. In direct variation, what ends up happening is that one variable directly affects the other variable. Classic example of this would be you go into a store, you buy a t-shirt, it's going to cost a certain amount. You buy 2 t-shirts that are the same type of t-shirt, it's going to cost double that amount. If you buy no t-shirts, it's going to cost you nothing. So it goes up a set amount for each one you buy. So that happens a lot with buying things and other things too. So let's look at the examples here and the definitions. So it says here, two variables show direct variation, provided y equals ax and a doesn't equal 0. And again, a is just a different way of referring to slope. Non-zero number a is called the constant of variation. Like I said, that is just a specific term used when you have direct variation for slope, which is m normally when we're working with it. If you want to think about it just as m, that's fine. The equation y equals 3x is an example of direct variation, and the constant of variation is 3. Because again, that there, the number in front there, is the slope. It's also the constant of variation. So those two things are the same. One thing to know is that always in a direct variation equation, 0, 0 is going to be a point. So that works for this equation here because 0, when you plug in the y, is equal to 3 times 0. So that does work. The next one, it says here, the equation y equals x plus 3 is not an example of direct variation. And the way we test that is by trying this point here. So it's going to be 0 for the y. Is that equal to 0 plus 3? No, it's not, because then you have 0 is equal to 3. So that's an example of an equation that does not have direct variation. So the quickest way to just do this is to just plug in 0, 0. So we're going to look at a couple examples here. So for this one here, if I plug in 0 and 0, I end up with 6 times 0 plus or minus 3 times 0 is equal to 12. So is 0 minus 0 equal to 12? No. So this does not have direct variation. The next one over, plug in again 0 and 0. And see if it works. In this case here, you're going to have 0 plus 0 is equal to 0. So yes, that does work. I'm going to pause here for a second. See if you think the next two direct variation works for. So in the first one in blue, the answer is yes, it does work. The one in red, the answer is no, it does not work, because in one it adds up to 0 on the left-hand side, that equals 0. And the other one, it adds up to 0 on the left-hand side, and it's equal to 1 on the right-hand side of the equation. So in this slide here, it's talking about direct variation equations and graphing direct variation. So in this case, it says here y is equal to negative 4x. That's an example of an equation with direct variation. And immediately I can plot the first point, which is going to be 0, 0 right there, since it's direct variation. And if you wanted to just test it, you could also see that that does work, 0, 0. And remember, negative 4's slope is negative 4 over 1. The top number is the change in y, the bottom number is the change in x. So what I'm going to do is I'm going to go over 1. Go over 1. And then I'm going to go down 4. 1, 2, 3, 4. And that's going to be my next point right there. Now I can do it again, over 1, and then down 4 again. 1, 2, 3, 4. Okay, so that's going to be my equation right there. That's going to be my line. And that's all you have to do. Next one over here, you can give it a try yourself. Remember 2/5 as an equation. This is going to be the change in x. This is going to be the change in y. And try and graph it yourself for a minute, and then I'll pull up the graph. So pause here for just a second. And that's how that line should look, because 0, 0 is the first point, then you go up 2 and over 5, and up 2 and over 5 again. So in this one here, it's a little bit different. It says graph the graph of direct variation is shown. Write the direct variation equation. Find the value of y when x is equal to 14. So I've got a point listed here, and the point is 2, 3. Remember, 0, 0 is also a point. So if I wanted to, I could figure out the slope. The slope would be change in y, 3 minus 0, over change in x, 2 minus 0. So the slope is 3/2. Since it's direct variation, the full equation is going to be y is equal to 3/2 x. And now I can plug in this here. When x is 14, what is y going to be? And I got to do that over here. When x is 14, I end up with y is equal to. So it's going to end up being y is equal to 21 when x is equal to 14. Because I'm plugging in these numbers. I plugged in 14 here, over here, and that's going to be 42 over 2, so that's going to end up with 21. So my final answer is going to be that y is going to equal, when x is equal to 14, y is 21. So here's one of those examples where we talk about buying something in direct variation. And it's talking about DVDs and the total cost depending on how many you buy. So naturally, if you go into a store and you buy 0 something, it's going to cost you $0. We can come back to that in a second, but let's look here. If you buy 3 of this, it's going to cost this amount. If you buy 6, which is double 3, it's going to cost double the amount that 3 would cost. If you buy 9, then it's going to be triple the cost that it was for 3 here. So it's an example of direct variation because the cost goes up consistently. And if you buy 0, then it's going to cost you 0. Whenever you have a situation like this, one of the things you can just do is you can notice that there's a ratio between these two numbers. If I treat this as x, my independent variable, this is y, my dependent variable, because x is the thing that determines y, in this case here. So that means I can just set up a ratio of this over that. And the reason why I can do that is, since I know if I bought 0 CDs or DVDs that would cost $0, I could actually figure out the slope here. So the change in y is going to end up being $25.77 minus 0. The change in x is going to be 3 minus 0. So if I just divide 3, because I end up with 25.77 over 3. If I divide 3 into $25.77, I can write a direct variation equation really easily. But I can just do it right now. This is the direct variation equation is going to be, not be simplified, but it will be $25.77 over 3. That'll be x, but in this case here we're going to use D and C. So the total cost is equal to $25 divided by 77, or $25.77 divided by 3. That's going to get me to that each DVD is going to cost me $8.59. So the total cost is going to equal the amount of DVDs you buy times $8.59. And that's a direct variation equation. So when you're graphing using direct variation equations, it's, like I said before, simpler because you just have this one thing to worry about, which is the constant of variation, which is also known as slope in a direct variation equation. And you can use that to quickly plot points because you know 0, 0 is going to be a point. And once you know 0, 0 is going to be a point, then you can just graph the next point pretty quickly using the slope form that we've been doing before.